Yo, what's up guys? Welcome back to another video. Today with us we have the one and only, the almighty Fedora Linux 44 KDE Plasma Edition. So this is one of the better distributions that's out there. People claim that this is the best, and I tend to agree. KDE Plasma, man, this is an amazing desktop environment. This looks and feels like Windows. People coming over from Windows, they feel familiar using this. We have beautiful animations, beautiful blurred shell. We have panel configurations and whatnot. This is the pinnacle of Linux that we're about to find out. So without wasting further time, let's just dive right in. Alright, welcome back to Fedora 44. Now the first order of business is we're going to go ahead and install it to our hard drive, and this is going to be an actual install this time around because there is a difference. There is something new in the now may improve before this. In version 44, the Anaconda installer Plasma setup application replaced with accessibility. However, this modern look ARM64 Live ISO work out of the box on Windows ARM laptops. Thanks to automatic device tree blob selection at boot, the installation process is now much
Okay, so hi everyone. Hope you guys had a good week. With me and Sean, we have labeled ourselves with the Notion Campus Leader. We'll be presenting, and then we have Min Jun here also. It's part of the NUS Hackers team who organized this with us. So today will just be a continuation on what we did last time. If you guys were not here for the last one, then there's probably a recording that will be sent if you guys want to watch it. And then we're gonna be continuing from where we left off. So just a recap. Last time, another team member from NS Hackers went through how to build a very simple MCP client and an MCP server. And then he used the example of counting the number of R's in a strawberry as an MCP server tool that MCP AI agent can actually use to perform tasks. So today, our main agenda, I'll start sharing my screen now, is to actually go on a slightly more application layer and show you guys like what you can do with MCP. So can you guys see my screen? Okay, great. So just scan this QR code. I will also send the link to this page in the chat for you guys to access. It is the materials, the slides we're using for this workshop. So, okay, I can't find the Zoom, so I will. Sean, can you send the link in the chat of the slides?
Yeah, sure.
Thank you. Yeah, so just follow along, and if there's any questions you have, don't be afraid to pause me if you want to ask. And hope you guys have a good time as well. All right, so today's topics, we're gonna be creating an MCP server for NUS mods to help you guys do your mod rec. And then we'll be deploying it online to prefix infrastructure, and then we will connect it using Cloud Desktop. And then this is the first part that I'll be covering with you guys. And then the second part by Sean will be introduction to Notion MCP, connecting the Notion's MCP server to your client, as well as another demo to show you how to do that. So, more right, everyone hates it, but you have to do it like 8 times in your 4 years of school. It takes about like so long, and we just want to make it a bit easier for you guys by using some of the current tools that just came out not too long ago. So we're going to be creating an NUS Mods MCP for NUS Mods API. All the links to the APIs and the source code and everything will be sent later as a link tree. So don't worry about that. Just follow along. So we're going to be using Claude as our main orchestrator. And then later on, we'll be using Notion MCP as well to show you how to use kind of Notion in your workflow, because we are Notion ambassadors, campus leaders as well. So we want you to get to see how useful it can be to use Notion. Okay, so this is the source code. The links are up on top. So there's one that is, the first link is the one that I'll be using for the demo. The one below is another version that has just much lesser tools and something that you can probably clone to write your own MCP server from there. So mine is a bit like more exhaustive. Have a bunch of tools like get module, search module, filter module, that basically allows you to plan your module be better using the AI. So we will not go into that. So there's also a URL here. So if you want to follow along, just
you can think.
Hopefully you guys already have your desktop. So this is just a screenshot of how it looks like once, because it's a custom MCP here. Yeah. So what you need to do is to press the hosted option. And then over here, I've already connected my GitHub. So if you don't have a GitHub, I think this is my own repo, so I can't work it. So just click to enable that MCP. But once it's after the workshop, it's done, you should have your own URL, because I don't know whether I'm going to. Similar to what the presenter showed in the first part of the workshop, you can run the MCP server in your computer and use, like as I mentioned, standard IO to call the MCP server. So this is the local version. I'm gonna open a new chat, and I'm just gonna ask it a few questions, right? So let me go back to the slides and copy some of the suggested prompts that you saw just now. So, okay. In this case, as I've shown you in the screenshot just now, if you navigate to the plus and connectors, and then you scroll down, you also see that it's enabled here. So sometimes if, let's say there's an error or there's a tick next semester, if I'm interested in, let's say deep neural networks. Yeah. So in this case, it should have access to all the tools, and I don't think I need to prompt it to actually use the right tool. Yeah, so it's loading the tool you can see here. Oh, it's so fast. Yeah, so yeah. I think because I used this tool before, it has some kind of context that to call this tool. So if the AI didn't get it the first time, you can just present it in not no, because it already knows what tools it has access. Not gonna be good. Now, what it did was give, and then after that, I can unmute yourself also because I'm currently on the slides. I don't see your.
In the previous, the whole module list, and then it will filter through that. Yeah, it should give me. There's a lot more features like search, fetch, like your CRUD operations. Or like database queries. It should. Yeah, this is my. Only then I just let it and extracts the whole, all the context from the paper, tools, skills that you can project very like with natural language. So I say I want to build a translation playground using this model, and then using Hugging Face transformers V4. So I give it a few details so that it knows it doesn't like hallucinate and use whatever it wants. So I guess you should to use Prefect Horizon is because it takes care of all of that for the previous presentation. So
So welcome everyone. Let's get started with our last one. But so to explain agents. So let's forget the code base I made you guys clone for a second. Imagine you're talking to an AI assistant and you type that okay. So on workshop.py, it's the same tool result. Now you guys encountered the tool and tool result data class that the tool okay, that this tool reads the content of. Before we continue, just I wanted to make sure that everyone is understanding so far. This function will take all of your files that are. I haven't done this, but a lot of like production level agents they. Now this function is I'm calling this function over here to update the agent state, so it has context of whatever is going on. Then I update the observation to be the tool result, and then it resumes the loop by then the loop gets resumed and the observation is updated. So now the agent knows that okay, last observation from this tool was this is this. So in the loop that I previously showed you,
Anthropic just released Claude Opus 4.7, and that means we have achieved AGI. Coding is dead, leak code is dead, everything is dead. Vim is dead. The benchmarks have been absolutely crushed. Now, in seriousness, I'll just go ahead and say it, that this model is not that significant. I don't believe that this is a very significant moment. If you're an AI hater like I used to be, or at least how people saw me, you might be wondering, well, when is there ever a moment or a model that releases that actually matters? Well, last year, I think, when Opus 4.5 released, I think around November, I think that was a moment that people probably needed to pay attention to. But I don't think that every month or every other week when releases a new model, I don't think it's, as big of a deal as most people make it out to be. And I think that this time that is the case. But I think there are a few things that are worth talking about, so I'm going to try to go through them. But I understand that some people are going to think that now I'm some kind of AI hype bro. And I do think that's a little bit funny, because what exactly are you guys coding, or is anybody coding, where LLMs are making the work 10 times as fast? But that's okay. Now, we're going to go through this. We're going to look at the benchmarks. We're going to look at what some of the people at Anthropic are saying. We're going to look at what a lot of the users are saying, because it's been a very interesting few weeks at Anthropic for their PR. A lot of negative and questionable things. So in case you haven't been keeping up, this is Anthropic's newest model and also the newest one available to the public, but it's not Anthropic's best model. That one is unreleased. It's called Mythos. It's the one that they said is too dangerous to release, more of an art than a science. But we have seen recently that this study from Berkeley, I won't go through this, maybe it warrants a separate video, but the TLDR is that basically AI agent benchmarks can be gamed, and they have been gamed in the past. And that's something I feel like any reasonable person could tell, that it's not just in the way that like they're calculated, but even we've seen sometimes that like the companies, cybersecurity vulnerability reproduction, it's slightly worse in a few ways. I'll talk about that as well, but use it enough to realize that it is absolutely better than Opus models. I used to use it in open code, but they made that not allowed. Access to it. Maybe I should models at this point are thinking. And so some people are mentioning that maybe this is another way that Anthropic is trying to save on compute, that actually since the model takes more tokens, that's not really the case, but who knows? Thinking is the only thinking mode, and by default, it is off. Why did they deliberately make that choice? I can only guess. Basically, instead of you now being able to choose whether the model that you're paying for or using is going to be thinking, Claude is going to make that choice for you. And that sounds really nice, but what if it's wrong? It's wrong all the time. So now basically, the request that you make, Claude is going to evaluate the complexity of it to determine whether it should use extended thinking or not. And it looks like it is somewhat dependent on the effort level that you set. So if but think they're trying to not really being transparent about. This part is going to be a bit controversial because they said that we would keep Claude Mythos is preview release limited, but they're also going to test new cyber safeguards exploits in any type of like software that's running that's not legal, but if you can still do that, there's going to be obviously issues from it. And so Anthropic is trying to do the right thing, but I think people are always... The creator and the person running Claude Code at this point said that Opus 4.7 uses more thinking tokens. And I think the number is like roughly 35% more. So they've actually increased rate limits for all subscribers to make up for that. People asked, of course, easily switch to Codex. There's some minor things like it's supposedly supposed to be better at literally following instructions. So hopefully when you have a prompt, bad PR lately. And so here's the mention about them using an updated tokenizer. That's a bit of a conspiracy theory. I think it is technically possible, but I think it's more likely that there's some like other side effects going on. Like maybe they're just doing it because of like the GPU shortage or some other reason, because it's not really in Anthropic Hey everyone, welcome back, and let's write some more neat code today. So today let's solve gas station. This I'm just going to tell you off the bat, this is a greedy problem, and it's actually kind of difficult for me because this is a problem that's pretty unique. You're not going to find a lot of problems like this on LeetCode. So we're given n gas stations along a circular route where the amount of gas at the ith index is just the value in that input array. We're also given a second input array telling us the cost at every single position for us to move from the ith position to I plus 1. So at every position, we have a amount of gas that we can pick up, and we also have the amount of cost it's going to take for us to move to the next position. So we begin our journey with an empty tank of gas, so we don't have any gas, and we start at one of the gas stations. It could be any of the gas stations. And so given these two integer arrays, we want to return the starting gas station, the starting position, the index that we start at, such that we can travel around the entire circuit. Like basically we can go in an entire circle in the clockwise direction without running out of gas. And if that's not possible, which possibly could be the case, right? In that case, we're going to return -1 because there is no valid index. But if there does exist a solution, it's guaranteed to be unique. So that's good for us. We don't have to worry about multiple solutions. So this problem is best understood with an example, so let's look at the given example. So I'm going to take these two input arrays and draw them on top of each other because that makes it a lot easier to visualize what's going on. So I've lined the arrays with each other. Now let's actually look at the differences, right? So we have our gas, right? Gas is good because it lets us move to the next position. Cost is bad because we have to spend gas to be able to move to the next position. So let's just subtract cost from gas and then create a new input array just to help us kind of see what's going on. So 1 minus 3 is going to be -2, right? So if we start at this position, we just can't get to the next position, right? We have 1 gas, but it takes us 3 to get to the next position. We simply don't have enough if this is our starting position. Let's look at this one. 2 minus 4, that's also going to be -2. Again, we don't have enough gas if we're starting at this position to move to the next position. Let's do this one. 3 minus 5, once again, -2. And now let's look at this one. So 4 minus 1, that's positive for once, so that's going to be 3. And once again, we have 5 minus 2, that's also 3. So the brute force way for us would be to try every single starting position, like try this starting position, try this one, etc. And then keep from that starting position, keep going until we make a full circle back here and then see, did we ever become negative? Did we have enough gas to continue to move us, or maybe the cost was too high and we just got stuck? We could not complete this circle. That overall time complexity though is going to be n squared, right? Because let's just run through it, right? Starting here, we would potentially go through the entire array. Starting here, we'd potentially go through the entire array, right? Basically, that's how it would be. But in this case, we can see that since this is negative, right? It's just right off the bat, this is not going to work. This starting position is not going to work. What about this one? It's also negative. It's not going to work. This one's also negative. It's not going to work. This one is positive, right? So since the difference is 3, that means that even after we move to the next position, we have 3 gas in our tank, right? So now we're here, right? So far we have another positive 3. That's good. So now we have 6 gas in our tank, right? We started here, we moved here. Now we're going to go back in a circle, right? We have 6 gas in our tank. Now we have a -2. So we -2 from here, right? That's going to leave us with 4 gas in our tank. Now we're going to be over here. That's going to leave us, we're going to end up using 2 more gas over here. That's going to leave us with 2 gas remaining, right? So now we're going to be in this last position, and we have to spend exactly 2 gas. That's going to leave us with 0 gas left over. But the good thing is we do make a circle. We do complete the circle, we do move from here back to the starting position where we started. So what does that tell us? That tells us since we started over here, we were able to complete a circle. What's the index of this position? 0, 1, 2, 3 is the index of this position. So we end up returning 3. We can see that that's basically what they explained in the explanation of this problem. And remember, they told us that there's only going to be one unique solution if one does exist. Would this starting position work? It would not, because if we start here, we have 3 gas in our tank, right? But then we see that there's this portion, right? We're going to be going in a circle. We're going to come back over here. This stretch of -6 in total, we have 3 gas. We're not going to be able to complete this -6 stretch, right? So we have to start from here to get all of this gas before we try to tackle this negative portion. By the way, one important thing to notice is the sum of the gas has to be greater than or equal to the sum of the cost array. I'm talking about the total of both arrays, right? The sum has to be greater or equal. That makes sense, right? How can we complete a loop if we don't have enough gas to cover the total cost, right? It just simply would not be possible, right? And no matter how we do it, right? So if I had, let's say this was our gas array, so the sum in this case is equal to 3. And if we had a cost array of the exact same, right, 3, we would have enough gas to make a loop, right? So in that case, we would not return -1. Now, technically, this is actually not possible, because notice how in this example, if we start here, we would be able to make a loop, right? If we start here, we would also be able to make a loop. If we start here, we'd also be able to make a loop. We can't have multiple solutions to this problem, so this actually would not be possible. Something more realistic could be something like, maybe these two are actually 0, right? And this one is 3. So this would be the solution in that case, right? If we start here, then we're able to make a loop. So now let's actually get into why this problem is greedy. It's kind of hard to explain because, to be honest, this problem isn't really intuitive for me. But one thing to know is, first of all, the sum in this example, we're going to be going through the same example. This is the difference array that I just redrew for us. And the first thing we're going to check in this problem is we're going to make sure that the sum of gas is greater than or equal to the sum of cost. In this case, both of the sums are exactly equal to each other, so we know that there exists a solution. We don't have to return -1. We know there's a solution to this problem. So now we're actually going to go through the greedy portion of this algorithm. We're going to keep track of one single variable, our total. Actually, we're going to keep track of the total and the start position, but I'm not going to draw that. So first, we're going to consider maybe this is the solution. The first position is the solution. So we're going to take this value and add it to our total, which is initially 0, but we're adding this -2. So now our total is going to become -2. If our total ever becomes negative, meaning less than 0, that means we ran out of gas. That means this start position did not work. So what are we going to do? Well, we tried this position, it didn't work. So we're going to be greedy now. We're going to say, okay, this didn't work. Let's just try the next position now and just keep moving. We're going to take our total, which was set to -2, but we're going to get rid of that and we're going to reset the total to 0. We tried this position, it didn't work out for us. Now let's move to the next position and try it. So what's the total here? It's -2, right? That's the difference. So now we're going to take our total and and add to it -2. So it's going to become -2 because it's 0 right now. Now, again, this is less than 0. It's become negative. That means we ran out of gas. That means this starting position does not work as well, right? So what we're going to do again is take our total, reset it back to 0, and cross this out because it didn't work as a starting position. Try the next starting position. We're being greedy. Every time a starting position doesn't work, we just restart. We reset the total and we try the next position. Basically, since it's another -2, we're going to repeat the exact same thing. This is going to become -2. It's less than 0. It didn't work out for us. We have to reset the total back to 0 and then say that this position did not work as the starting position. So now we're here, right? We're at the 3. We're going to add 3 to our total. right? So now our total becomes positive 3. Okay, that's awesome because it's finally greater than or equal to 0 for once. So now we're just going to keep continuing. We're going to be greedy. So far, this has been working for us. Let's just keep going. How long is it going to work for us? Now we're going to move to the next position, right? We're going to once again add this value to our total. Plus 3 is going to be 6. So let's set our total now to 6, right? And now notice how we have no more elements left in our input array. What does that tell us? Does that tell us we need to go back to the start and then redo a loop? Technically, no, we don't have to do that. Why is that the case though? Because that's not super intuitive. Well, first of all, remember that we verified that the sum of gas is greater than or equal to the sum of cost, right? So we guaranteed that there exists a solution. And we also know that this was our starting position, right? That allowed us to continue going all the way until we reached the end. We never became negative once we started over here, right? So and since our sum is, since we know we have enough gas to complete a loop, we know that a solution is possible. It has to be this position because we know that there's only one unique solution. It couldn't possibly be this one as well as this one. And also we know that since there definitely exists a solution, since we're starting here and we were able to reach the end of the array, that no matter how negative these values are, they're never going to make us negative because it's definitely possible to complete a loop. I know I'm not explaining this super well, and that's because this is not super intuitive. Either you know it or you don't. That's why greedy problems are really tricky because you kind of just have to assume that it's going to work and then just see if it does. But I think it'll make a little bit more sense when we look at the code because the code is pretty short and simple and concise and very readable. So let's actually look at the code. It'll probably make more sense. By the way, this is the greedy algorithm is O of n. We know the brute force was n squared because we'd have to potentially iterate through the entire array n times n squared, right? But with the greedy approach, we're actually able to do this in just big O n time and big O of 1 memory complexity. We don't actually need any extra memory. So as I mentioned, the first thing we're going to verify is that at the very least a solution exists. So if a solution does not exist, that means the total amount of gas is actually less than the total cost it would take us to complete a loop. In that case, we know that we have to return -1. That's just the value that they told us. Now, if we don't execute this, that means there's definitely a solution. We just have to find it. So we're going to keep track of our total, which is initially going to be 0. We're also going to be keeping track of our result, which is the starting position that we're going to return. Initially, that's also going to be 0 because we're going to be greedy. We're just going to try the first index and see if it works. And to do that, we're going to actually be iterating through every position in the gas array. And we know that the gas array is actually the same exact size as the cost array. So I'm going to, every position I, I'm going to take the difference between gas of I and cost of I, just like we kind of showed in the difference array that we had in the drawing. So I'm going to take this difference and I'm going to add it to the total. And remember, the only thing we're really checking for is that if our total, remember, we're being greedy. If the total dips below 0, that means this position does not work. If it never dips below 0, that means this position is going to work. So if it does dip below 0, that means this position doesn't work. So we're going to try the next position. So to try the next position, we're simply going to reset our total. We're going to set the total back to 0. And what are we going to set the starting position to? Since the current starting position, which initially was 0, didn't work, we're going to take the starting position and now set it to the next position. But we know for sure that for at least one position, at least one starting position, this algorithm will work, right? Because we're guaranteed that because this if statement did not execute. And that's actually it. This is the entire algorithm. It's not as much code as you would expect because as most greedy problems, it's about just identifying that the problem itself is greedy. after we're done executing the loop, we can simply return the starting position. The starting position such that the total never dipped below 0 after we got to that starting position. So to summarize, the main thing about this problem is identifying that it's greedy, and to be honest, I don't have a lot of advice for that. This is kind of a tricky problem for me as well. Maybe people in the comments will have some tips and tricks, or even maybe an exact proof of why this problem works. But I hope that this does give you a general overview